Hello, you absolute legends. My name is Don Cavanaugh, and let's talk about the final thermodynamic term, entropy. We've talked about G. G wants to be a positive or negative value and can tell us about the spontaneity of a reaction. We've talked about H. H can be positive or a negative value, and it tells us whether it's exothermic or endothermic. We've talked about K, and K can be greater than 1 or less than 1. K can be greater than 1 or K can be less than 1, but K can never be 0. K can never be a positive value right there, and that tells us whether the products or reactants are favored right there. S. S for entropy. S refers to the position, movement, vibration of the molecules. Molecules are moving all the time, every time, and this movement is directly related to the temperature of a system. The entropy of a system is going to be a positive or negative value, an increase or decrease in entropy. The units for entropy are joules divided by Kelvin or temperature. We said that it is related to temperature, directly related to temperature, so we see division going on here. To predict and calculate S are the two skills. Prediction will be your first skill to learn. Prediction of an increase or decrease in entropy. First thing you look at is you look at the state of matter. Right? So look at a state of matter right there. Second thing you look at is the complexity of the molecule. State of matter. If things are going from a gas to a liquid, that is a decrease in entropy. It is getting more ordered. If it is going from solid to liquid, that is an increase in entropy. It is getting more disordered. There are more positions, more movements, more vibrations. Let it be said that when going from solid to liquid, there is often an increase in energy and temperature, and when there is an increase in temperature, there is an increase in vibration or motion here. So when we are trying to predict changes in entropy, the first thing we look at is states of matter right here. Another example, let's say I have one solid. Let's say I have a liquid that is, let me go to complexity right here. When predicting complexity of entropy, we look at these two molecules here. This one is going to have a higher entropy. It is more complex. It has more vibrational states. If we look at the Lewis dot structure and its connectivity, okay, we have more vibrational states, more different positions, more different movements, more types of vibration. We're not talking about comparing melting point or boiling point. We are comparing the complexity of the molecule right here. Another example. H2 versus H2O. This is going to have a higher degree of entropy. It has more complexity to it. Let me throw something at you here. What if I have, this is a solid, and let's say this is a gas, okay? This, with the state of matter, is going to have a higher degree of position, movement, vibration, an increase in entropy right here. When talking about entropy, your first job is to predict. You'll use the states of matter, what we know about solid, liquids, and gases, and then complexity of the formula being the second thing to consider. I hope this helps. Thank you.